This is 5.10 Student Notes, General Trig Equations. You notice it says solve the equation in the indicated domain. This means that you're doing the general solutions and then you're finding answers that fall between 0 and 360. You are going to be doing degree equations as well as radian equations. Okay, so the first one, let's go ahead and simplify this. The first thing I would do is go ahead and move my 2 over. So this is going to be sine of theta plus 47 degrees is equal to 1/2. Move my sine over, so theta plus 47 degrees is equal to arc sine of 1/2. Okay, from here, let's go ahead and draw a triangle and figure out where everything falls. Remember, arc sine is on the side, and this is positive. So 1/2 is here, and this is √3. So it looks like your principal value is going to be 60 degrees. Nope, to be 30 degrees. And since we're in degrees, I can leave it as 30. So my first equation is going to be theta plus 47 degrees is equal to 30 degrees plus 360, because that's what you add to each equation. Okay, so for my second one, we're looking for where else is sine positive. So we did all students take calculus, so I did positive here. So it looks like my second equation is going to be over my second quadrant. So in order to get here, I'm going to have to subtract from 180 degrees. So it looks like the second will be 150. So I'm going to say theta plus 47 degrees is equal to 150 degrees plus 360 n. Okay, make sure you add your n on both of those. Then we need to solve for theta for both of them. So theta is going to be equal to negative 17 degrees plus 360 n. That's your first general solution. And then for the second one, theta is going to be equal to 103 degrees plus 360 degrees n. Okay, there's both of your general solutions. Okay, and remember your domain, I want answers that fall between 0 and 360 degrees. So let's see, how about 103 degrees and 343 degrees? Remember, I'm just plugging in answers for n to get solutions. Okay, number 2. Now this is where people get messed up because there's a squared. Now let me show you what to do. I would go ahead and divide by 4. So that gives me a cosine squared theta is equal to 1/4. To get rid of the square root, to get rid of the square, I would square root both sides. When you take the square root of 1/4, you're going to get a positive and negative 1/2. Okay, so I'm going to take these apart and do 2 different equations from this. So over here, I'm going to take cosine of 1/2. And on this side, I'm going to do cosine of negative 1/2. Now these are not my general solutions. I'm still just solving my regular equation. So over here, this is theta. We are in degrees. Theta is equal to arc cosine of positive 1/2. So positive 1/2, I can go ahead and draw my triangle, is going to be in my first quadrant. So this is 1/2, and this is √3. So my principal value is going to be 60 degrees. And so my first equation is going to be theta is equal to 60 degrees plus 360 degrees n. And thank goodness there's nothing else here. That is my general solution, which is super easy. Okay, so where else is cosine positive? If this is all students take calculus, looks like my other triangle is going to be down here. And I like to just do the negative version of this. It makes it so much easier. So my second equation is going to be theta equals negative 60 degrees plus 360 degrees n. And again, you don't have to do the negative version. If you would like to go all the way around and do 330 degrees, that's totally fine as well. Or I guess that would be 300 degrees positive. Okay, let's go ahead and solve this equation as well. So I'm going to do theta is equal to arc cosine of -1/2. Now we need to find our general solutions and principal value for this side. So cosine is on the top and negative would be over here. So this would be -1/2. This would be √3. So this is 60 degrees here, but what gives us this is going to be 120 degrees. So this is our principal value. Okay, let's see. Theta is going to be equal to 120 degrees plus 360n, and that is your first general solution. I'm going to say this is equivalent to -120 degrees plus 360. And again, if you don't like the negative version, it's fine for you to say 120 plus another 60, and you can say that's 240 for your other general solution. Okay, so between these four general solutions, I want answers that fall between -180 and 180. So that's going to be -120 degrees, -60, a +60, and a +120 degrees. Okay, for number 3, I think the biggest thing that people try to do here is they try to divide by tangent. We've got to make sure that we're still solving these in the correct manner. So what I'm going to do is to subtract tangent theta from both sides so that I have everything on the same side. So subtracting on both sides, I end up with tangent theta secant theta minus tangent theta. And that's going to be equal to 0. Okay, so now I've got two numbers, and both of these numbers have a tangent theta in them. So I can factor out a tangent theta, leaving me with a secant theta minus 1. And I'm still equal to 0. Okay, the nice thing about this, I can now take each part of this and set it equal to 0 and solve. So I'm going to split this up, leaving me with tangent theta. This reminds me of working with quadratics back in algebra. So tangent theta is equal to 0, and I'm going to come over here and say secant theta minus 1 is equal to 0. So I have two equations that I can solve now. So I can solve this for theta, and this gives me arctan of 0. And so arctan of 0 is 0. So my principal value is 0. So when you're writing your equation, remember tangent only has one equation. So that would be 0 degrees plus 180 degrees n. And you can leave it this way, or you can go ahead and simplify this and say this is really just 180 degree n. And I would take either one of these. It's totally up to you, simplified or unsimplified. Okay, for secant, we need to move the 1 over. So this is secant theta is equal to 1. Then that would be arcsecant of 1. And you can think of arcsecant of 1 is going to give you, of course you can't look into the table, but you can think of arc cosine and do the reciprocal. And so that is going to be, general solution is going to be 0 again. And since we're looking at cosine, that is going to be 360 degrees n. It looks like no matter what we do here, we're still going to get 0 degrees. Same thing. It's still going to be 0 degrees plus 360n, like I said. Okay, and if you wanted to, you could go ahead and just say theta is equal to 360 degree n. All right. Okay, now realistically, you have 180 degree n and 360 degree n. There's no reason for you to write both of these, because if you say 180 degrees times any variable, you're still going to get this 360 degree n. So If you wrote just this one equation, you would be good on your answers. Now, the one thing that I like about this answer is that there's no way you could find every answer, every degree. So anytime you say real number of degrees, you're only looking for your general solutions. Okay, so you're done with this problem, which is super nice. Okay, for the last one, we're going to do some different things on this one. We are in radians, so I want answers from negative pi to pi. And this one is a trinomial, 3 minus 3 sine x minus 2 cosine. Now, I do notice I've got a sine and a cosine, but I did notice that it's a trinomial. So I'm going to try to replace this so that I've got all signs. So 3 minus 3 sine x minus 2, and I'm going to replace that cosine with a 1 minus sine squared. And I'm just trying to get it to where I can work it. So I'm going to distribute this. So this is 3 minus 3 sine x minus, actually this is, yeah, that's going to be minus 2. And this is going to be a plus 2 sine squared. All right, I can combine the 3 and the negative 2. And I am going to put it in descending order so it looks a little bit better. So I'm going to put my sine squared first. So this is 2 sine squared x minus 3 sine x. And then I'm going to say plus 1. Okay, so now I've got a sine squared, a sine, and then a 1. Now this is something that you have not seen, but you're going to be using a lot of it. I'm going to say let sine x equal u. Now I know this is a weird letter for everything to equal, but this is called u substitution. Okay, so I'm going to say 2u squared, because I'm replacing the sine x, minus 3u plus 1. And hopefully this looks like a very normal problem now, and I'm going to do some factoring now. So I'm replacing the 3u. So I'm basically 2 times 1 is 3. What factors of 3 give you negative 3u? And that would be negative 2 times negative 1. And now I'm replacing them in. So this is 2u squared minus 2u minus 1u plus 1. Okay, so these two add up to the middle number. So now I'm going to group them, the first two and the second two, and take out a common factor. And that would be a 2u. When you take out a 2u, you're left with a u minus 1. Take out a common factor here, and there's really nothing except for a negative 1. Then that leaves you with a u minus 1. So my answer here is 2u minus 1 and a u minus 1. Okay, so now I'm going to keep solving these. I need to come over here. This gives you, remember when you're working with quadratics, this is 2u minus 1 equals 0, and a u minus 1 equals 0. So moving the 1 over, u is 1/2, and over here u is 1. Now remember we plugged in a u, substituted it, so I'm going to replace that substitution. So really, this is sine x equals 1/2, and this is sine x equals 1. Okay, so I put the substitution back in. I did all the hard work. Now I'm going to get my general solutions. So my general solutions, I'm going to move my sine over. So this is arc sine of 1/2. And this is x equals arc sine of 1. Now to get your general solutions, I need to draw my triangle. So this would be 1 over 2. This is root 3. So my principal value here is going to be 30 degrees. So it looks like my first one is going to be x equals pi over 6 plus 2 pi n. And to get my second one, all students is going to be over here. So I'm going to have to subtract. That's going to be x equals 5 pi over 6 plus 2 pi n. And there's my two general solutions. Okay, let's go ahead and find the general solutions for this side. In order to be 1, it looks like I'm going to have to go refer to my OIO chart. In order to have an angle that is 1, it looks like it's 90 degrees. So let's see, x is equal to pi over 2 plus 2 pi n. And it looks like no matter what I do, the only thing that gives me 1 is 90 degrees. So both equations are going to be the same thing. So really no need to write my second one. It's the same thing. So here is my only equation for the angle that gives me 1. So let's find answers that fall between negative pi and pi. That's going to be pi over 2, pi over 6, and 5 pi over 6. Those are the only ones that fall between negative pi and pi.